Hi students, welcome to the class. In this class, we are studying about different type of registers and different type special function registers in 8051. Okay, these registers are used to program and control various on-chip hardware peripherals and features of 8051. Each special function register, that is SFR, has a name which specifies the purpose of SFR. Okay, each has its own name for special function register. Since special function registers are programmed by instruction, they are given address of unavailable RAM locations. Okay, only 21 locations in the SFR space are used in 8051 for implementing the SFRs. So we have 21 special function registers, or there are 21 locations which are reserved for special function registers. So each register have different name. Okay, it is illegal to access other location in the special function register space. Okay, in the total register space, we are using only 21 locations for space for special function registers. Other locations are vacant. Okay, out of 21 location, 11 locations are bit addressable special function registers. Okay, these are the 21 registers of special function registers. First, we can talk about math register. Math registers are important registers, that is A and B register. We have already know that A register is also called accumulator register. So we can study each and every one in detail in the comment section. Okay, so next one is status registers. That is program status word. It's also called flag register. This status register will give the status of the accumulator result. So the result is stored in accumulator, and the status register says the status of the result, that is the parity, auxiliary, carry, overflow, etc. are the are the elements of status register or program status word or flag register. The other register, that is 1, 2, 3, 4th register, is program counter. It's a 16-bit register. Then the other register are pointer registers like data pointer, DPTR, it's a 16-bit register, and stack pointer, SP. Then other input-output port latches are P0, P1, P2 and P3. Then other peripheral data registers are TL0, that is TH0, TL1, TH1. These are based on timer registers, and a buffer register, that is SBUF. Then other control registers are IP, IE, these are interrupt registers, and T-mode, T-con, S-con and P-con. These are other control registers. So we can discuss each and every registers in detail. Okay. Then the first register is A register of 8051, or it's also called accumulator register. It's 8-bit register. In most arithmetic and logic operation, the result A hold the first operand and also get the result of the operations. Okay, hence register A is also known as accumulator. So the result of the register is stored in A register, and so also hold the first operand. A hold the first operand also. Moreover, it is the only register to be used for data transfer to and from the external memory. In order to transfer data to the external memory, from the external memory, we are using accumulator A register. Several functions apply exclusively to the accumulator. Okay, we will discuss different instructions and functions in later sessions. So from that, we will be clear that there is exclusively some functions for accumulator, that is for rotate. In order to rotate a particular bit, we only use accumulator register, and parity computation, testing for 0 and so on. So there's some particular applications or exclusively for accumulator register, not other register. Then the second register is B register. It's also an 8-bit register. It is mainly used for multiply and divide operations. Okay. Then the other register is program counter or PC. So PC means program counter. It's a 16-bit register. It holds home address of the next instruction to be fetched, since ROM is program memory. That is, we have already discussed that is program counter save the address of the next instruction to be executed. PC get automatically increment to next location as soon as any instruction is fetched. So as soon as a single instruction is fetched, then the program counter will increment one address increment, and it will take the next instruction to be fetched. So always in program counter we have which is the next instruction to be fetched. So it's automatically increment the location to the next location. Okay, so program counter execute in sequential manner. In the case of branch instruction, a new address is located in program counter. ROM can be from internal ROM or external ROM depending upon the signal given to EA pin. If EA pin is set, then it will take the external ROM. If it is unset, it will take internal ROM. EA pin is active low pin. Okay. Now next register is DPTR data point. It's also a 16-bit register. It holds the address of data required in external data memory. It mainly deals with the external RAM. Okay, so if we are taking data from external RAM, we are pointing out DPTR data pointer. So DPTR can be divided into two sections, that is higher byte and lower byte. So higher byte can be pointed as DPH and lower byte can be pointed as DPL. Data pointer higher byte and data pointer lower byte. Okay. So used by the programmer to access data in external RAM. It serves as a base register in indirect jumps, lookup table instruction and external data transfer. These are the special functions of this DPTR register. Then the other register is PSW, that is program status word, and is also known as flag register. It indicates the nature of current result after every arithmetic or logic operation. They are changed by ALU. They can also be changed by the programmer if we are needed. PSW is both byte addressable and also bit addressable. Okay, so we can take byte at a time and we can take each bit at a time in the case of PSW. So this is the flag register or PSW register. It's an 8-bit register. This is the first bit is PSW0, then PSW1, PSW2, PSW3, 4, 5, 6, 7. These are the 8 bits of flag register or program status word or PS register. The first bit is parity bit. The parity bit means we are count the number of ones in here. So if the number of ones are odd, then it will set as 1. If the number of ones are even, then it is set as 0. So the odd parity is called 1 and if it is 0, then it is called even parity. If the number of ones are odd, then we set parity bit as 1. If the number of ones are even, then we set parity bit as 0. Then that is PSW1. This is a undefined bit. Okay. So and then PSW2 bit. This is overflow bit. If there is an overflow occur, this bit will set. That is overflow in the sense if we are add two 8-bit numbers, if it exceed 8-bit number and overflow occur, or if there is a change in the sign. Okay, if there comes a change, if we add to positive number, if there is a confusion in the sign, then we can say that an overflow occurs. So to positive number adding, if we get a negative number, an overflow will occur. Okay. Then PSW3, then third and fourth bit is set as RS1 and RS0. It is present in internal RAM. We already said that internal RAM is 128 byte internal RAM. It has 3 terms, that is a register bank, bit addressable area and a scratch pad area. These are the 3 section of internal RAM. So this internal RAM can be studied in detail in coming sections. Okay. So this is the register area. That is, if it is 00, we take register bank 1. If it is 01, we take register bank. Sorry, if we take 00, we take the register bank 0. If it is 01, the register bank will be 1. If it is 10, we choose the register bank 2. If it is 11, we choose register bank 3. So RS1 and RS0 is used to selecting the register bank of the internal RAM. Okay, so in default it is taken as 00. Default value of register bank is 00. Then this is FO. It is the user defined register, FO. Then AC means auxiliary carry register, that is auxiliary carry bit, and CY is carry bit. So by adding two binary numbers, we will understand the value of parity bit, overflow, and auxiliary carry and carry bit. Auxiliary carry is nothing but if we add two 8-bit number, A 4-bit number is called nibble. If the carry is forwarded from one nibble to another nibble, that is auxiliary carry. After the addition, if a carry occurs, a carry occurs, then there is carry bit will set. Okay, so this can be explained by taking an example in the last section of this video. Okay, so R0, RS1 is register bank select bit. These are used to select the register bank. Okay, so CY is carry flag. If it is 1, then carry was generated out of MSB. If it is 0, no carry is generated. The carry flag is also serve as borrow flag for subtraction. So in the case of subtraction, if a borrow occurs, then carry flag will be 1. If there is no borrow, then carry flag will be 0. Then auxiliary carry, it will set 1. Carry was generated out of MSB lower nibble, that is 4-bit. Carry from lower nibble to higher nibble. If there is a carry occur from lower nibble to higher nibble, it will set then 0, no such carry is occurred. Okay. So the next is FO, that is FO means PSW 5, fifth bit of PSW FO. This is user defined flag available for user for general purpose. For example, can be used as sign flag. Then user will have to set this bit to 1 when MS bit of result is 1. Okay, so this is user defined bit. So user can define the base. If the user define this bit as sign flag, if the result of the bit MSB is 1, then is set to 1. Okay, so it is user defined bit. Then OV, that is overflow flag. For performing sign arithmetic tools, complement representation used for representing sign numbers must be represent the sign bit. Okay, so overflow is equal to 1 if result is negative number after addition of two positive number, result is positive number after addition of two negative number. Okay, so overflow will be set if we add two positive number, if the result is negative number, then overflow is set, overflow flag is set. Then if we add two negative number, obviously the result will be negative. But if we get a positive number, then overflow flag is set to 1. In other words, this flag is set whenever the result of sign number operation is too large to be represented using 8-bit, causing the higher order bit to overflow into sign. Okay, so a overflow flag has two conditions. One condition is if two positive numbers is added, we get a negative number, or if we add two negative number, if we get a positive number. So it's a ambiguity or confusion in the sign, it's result in overflow. Then the other type of overflow is that if you add two 8-bit number, then the result is greater than an 8-bit, then we can say that an overflow takes place there. Okay, now parity flag P. Here parity is defined as the number of ones present in the accumulator. Okay, so for odd number of ones, the parity bit is set to 1, that is odd parity indication. So for even number of ones, the parity flag is 0, even parity indication. Okay, only 7 out of 8 bits in PSW are meaningful bits. Okay, so from this 8 bit, only 7 is meaningful. The PSW 1 is not defined yet. Okay, so these are about the different types of registers, and we can discuss an example also. Okay, now we can look an example for overflow. If we are adding two positive numbers, that is 0 0 1 1 plus 0 1 1 1. When we add these two, we get 1 plus 1 is 0 with the carry 1, 1 plus 1 0 with the carry 1, 0 plus 1 is 1, 1 plus 1 is 0 with the carry 1, 1 plus 0 is 1. So this is the case of overflow, that when we adding two positive number, then we get it pretend to be get negative number. So there is a conflict between the sign. So this is a condition for overflow, and if the bit addition of two 8-bit exceeds 8-bit, it's also a condition of overflow. So a conflict in the sign, that is two positive number, by adding two positive number we get a positive number, but there is a confusion comes here, that so because of that, a conflict in the sign of the numbers, a overflow will occur. Now next we can consider what is auxiliary carry and what is carry. Okay, by adding these two numbers, that is FF and with the 0 1, we can write it as F means 1 1 1 1 and the other F means 1 1 1 1. So by adding this with 0 0 0 0 0 0 0 1. So by adding these two numbers, 1 plus 1 will give 0 with the carry 1. 1 plus 1 will give 0 with the carry 1. 1 plus 1 we have 0 with the carry 1. 1 plus 1 we have 0 with the carry 1. So this is a nibble. So this carry is forward to other nibble. Nibble means 4 bits. So this is a nibble and this is a nibble. So by adding these 4 bits, the carry is forwarded to the other nibble. So this is called an auxiliary carry. So in this case, when a carry is moved from one nibble to other nibble, this is called the auxiliary carry set to 1. If it is not carried to other nibble, then auxiliary carry set to 0. So here the carry is forwarded to the other nibble. Then 1 plus 1 will have 0 with carry 1. 1 plus 1 we have 0 with carry 1. 1 plus 1 we have 0 with carry 1. 1 plus 1 we have 0 with the carry 1. This is carry bit. So carry bit is set to 1 here. So this is auxiliary carry and this is carry. Auxiliary carry means if the carry is forwarded from one nibble to another nibble. Nibble means a 4 bit. One nibble to another nibble, then auxiliary carry is set. Carry means if there is after addition, if we got a carry, then carry bit will set to 1. If there is no carry, then carry bit set to 0. That's about auxiliary carry and carry bit and also overflow. Okay, now we can discuss a problem based on this. Okay, the question is find the status of each flag register, each flag in flag register while performing the operation 35H plus DEH. H means hexadecimal number. Okay, we have 35H means the binary of 35 is 0 0 1 1, then 5 is 0 1 0 1 plus 0 0 1 1 0 1 0 1 plus we have D as 1 1 0 1 and E as 1 1 1 0. So this is the binary of 35H and DEH. Now we want to add these two. By adding 1 plus 1 we will have 0. Okay, we can take a dot here. Okay, after enable 1 plus 1 is, sorry, this is not 0. 1 plus 0 is 1. 0 plus 1 is 1. 1 plus 1 is 0 with the carry 1. 1 plus 1 is 0 with the carry 1. So we have the carry is forwarded to another nibble. So auxiliary carry equal to 1 here. Then 1 plus 1 is 0 with the carry 1. 0 plus 1 is 1. 1 plus 1 is 0 with carry 1. 0. 1 plus 1 is 0. Then 1 plus 1 is 0 with the carry 1. Then we have 1 plus 1 is 0 with the carry 1. So we get 0 0 0 1 0 0 1 1. So we have carry. So carry bit equal to 1. Now we can write the flag register as. So this is the flag register. The first bit is parity bit and second bit is not defined and third bit is overflow bit. And this bit are bank register banks, that is we are in default we are written as 0 0. This is user defined bit and this is auxiliary carry and this is carry bit. This is parity bits, that is we have odd number of 1 we have parity 1. If we have even number of 1 we have parity 0. So here number of 1 1 2 3, we are not considering carry 1 2 3. So we have odd number of ones. So odd number of 1 the parity will become 1. Then overflow. This is 8-bit addition. It exceeded 8 bits. So an overflow will occur. So here overflow bit is 1. Then we have auxiliary carry. So this is lower nibble and this is upper nibble. So the carry is forwarded from lower nibble to upper nibble. So the auxiliary carry is 1 and carry. There occur a carry bit. So the carry is 1. So this is how a flag register, the status of flag register can be done by after addition of two binary digits. Okay.